the best.
So here's our.
Oh my gosh. Hi guys. This is a really neat project. Tell me about it.
So what we're gonna find out is orthophosphate is the best corrosive inhibitor out of out of the four corrosive inhibitors, which was orthophosphate and then glycol. I say the name.
Let's try it again. Polyethylene glycol.
Polyethylene glycol.
Yeah.
And then sodium silicate and methanol.
Fantastic. So how will you do this experiment?
Okay, so we have 4 beakers that are filled with H2O, and each one will have like a different corrosive inhibitor, and then there will be a lead-infested nail to see which one will be the best.
Okay. So tell me a little bit more about the hypothesis. You know how we use those sentence frames? So I'd love to hear your hypothesis using a sentence frame.
If we use orthophosphate as a corrosive inhibitor, then the water will have less corrosion because orthophosphate creates a protective layer between or inside the pipes.
That's an interesting hypothesis. Can you tell me a little bit about the chemistry behind it? What do you think the protective layer will do?
It will oxidize the lead-infested nail. Yeah.
It'll keep,
Yes.
it'll protect the lead from being oxidized. Oh my gosh, I love that you both used corrosive inhibitor and oxidation, being oxidized. So, questions?
When you guys created your procedure, how were you guys able to, how are you guys able to decide whether or not your experiment will be a fair test for each of these corrosive inhibitors?
When we wrote out the procedure, there was going to be 5 different beakers, but like 4 of them will be filled with like different corrosive inhibitors, while one of them won't have any, and it will just only have the lead-infested nail. Well, all 5 of the beakers will have it, but for the control group, which is just H2O and lead-infested nail, while the others will have like H2O and corrosive inhibitors and the lead-infested nail. So we get to also test out to see which one works the best amongst the 4 of the corrosive inhibitors.
How do you know if your inhibitors are effective?
If we get the results, if our results matches with our hypothesis, that's how we're gonna know if orthophosphate is the best corrosive inhibitor.
Did you guys draw a bar graph to represent what your expected data would be?
Yeah.
So let's look at a visual response to Leah's question, which was fantastic. Scarlett, do you want to tell me a little about this graph and why you think orthophosphate? Sorry.
In this graph, this is a chart about the amount of lead that will be found in each beaker with the corrosive inhibitors. And since like the control, right, it has no corrosive inhibitors, nothing to protect it from against the lead, it will have the most amount of lead inside it. And since orthophosphate is like the thing that,
Well, we said that since like our perspective was that orthophosphate will work the best among all the 4, so we would put less amount of lead in orthophosphate than the other 3 corrosive inhibitors.
Thank you, and thank you for highlighting the control group. I love that you brought it up here because I was going to ask you a question about it as part of your procedure.
Using this experiment, how could the results better people's lives in the future?
So that
Sorry guys.
so it will probably help like